Let's talk about the AI revolution's dirty little secret. It's gobbling up a truly staggering amount of our planet's energy. But what if the solution isn't on Earth at all? Some of the biggest names in tech are now seriously looking to space to build the future of AI. So, let's dive into this wild cosmic shift. And I want to be clear, this isn't just some abstract thought experiment. We're talking about a fundamental change in how we power our digital world. And if you listen to the people at the top, this new cosmic normal might be a lot closer than any of us think. Yeah, you heard that right. That is a direct quote from Google's CEO Sundar Pichai. He isn't talking about some distant sci-fi future, he's talking about the 2030s. The idea is that building AI's massive power-hungry brain in space will soon just be the standard way of doing things. I mean, what a statement. I know what you're probably thinking. It sounds like something straight out of a movie, right? So why on earth would anyone even consider something so incredibly expensive and complicated? Well, the answer isn't really about the stars. It's about a massive crisis that's brewing right here on Earth. At its core, the problem is actually pretty simple. The AI revolution runs on electricity, and it is consuming an absolutely mind-boggling amount. Our planet's power grids, they're already starting to feel the strain. And when we say data centers, forget about some dusty server closet in an office. You need to picture these massive, sprawling warehouses, acres and acres of them, just packed to the gills with powerful computers running 24/7. They generate a ton of heat and can use as much energy as a small city, all to power the AI we're all starting to use every day. And the demand is it's exploding. To really put this into perspective for you, just last year, data centers consumed over 4% of all electricity in the entire United States. That's a huge slice of the national energy pie going just to these server farms. And honestly, this is just the beginning. So if 4% sounds like a lot, brace yourself. This projection from the US government is kind of shocking. By 2028, that's just a few years from now, that number could triple to 12% of the whole country's electricity use. That rate of growth is it's not sustainable. And you can see this trend perfectly if you just look at one company. This is Google's own data. Their energy use more than doubled in just a few years. It went from about 14.5 million megawatt hours to almost 31 million last year. You can see why a trajectory like this just doesn't work long-term on Earth. So, if the problem is that we're running out of clean, accessible energy down here, well, maybe the solution is to go straight to the source. The ultimate power source, our solar system's very own giant fusion reactor, the sun. And this is where Pichai really lays out the grand vision. Why let ourselves be limited by Earth's power grids when we could just tap into the sun's practically infinite energy, completely unfiltered by our atmosphere? And this is way more than just an idea. Google has a real moonshot initiative for this called Project Suncatcher. The basic concept is either doing all the data processing right there in orbit where you have constant 24/7 solar power, or, and this is wild, maybe even beaming that energy back down to Earth. And they're not messing around. They're already planning their first pilot satellite launch for early 2027 just to test the tech. Now, with the technology this transformative on the table, it's really no surprise that Google isn't the only one in the game. A whole new kind of space race is starting to quietly heat up, with a few different players all trying to get the lead. Yeah, this is not a one-horse race. On one side, you've got the tech behemoth Google, but on the other, you have an agile startup called StarCloud. And get this, StarCloud is backed by some serious heavy hitters like Y Combinator and the king of AI chips, NVIDIA. And the real kicker? They have already launched their first AI satellite and are claiming they can get a 10-fold reduction in carbon emissions. The competition is on. Okay, the vision is absolutely spectacular, but the financial reality is just as staggering. The amount of money required here casts a pretty big shadow over this whole thing, and it raises a trillion-dollar question. Let's pull this back down to Earth for just a second. A report from McKinsey estimates that just building the regular data centers we need here on the ground by 2030 will cost over $5 trillion. So now try to imagine the price tag for launching and maintaining all of that in space. This also brings up a really big financial risk that people are talking about, known as stranded assets. Just imagine a company invests billions and billions of dollars in brand new data centers on Earth. But then, a few years from now, these space-based ones become the new standard. That massive investment on the ground could become pretty much worthless overnight. And this quote from that McKinsey report just perfectly captures the impossible situation these companies are in. It's a super high-stakes gamble. If you invest too much on Earth, you risk those stranded assets we just talked about. But if you underinvest, you're going to fall way behind in the AI race. It's an incredibly tricky balancing act. And, this whole thing goes way beyond just the money. It raises a really fundamental question about where our technology is headed. Is this a necessary leap forward for humanity? Or is it a super high-risk gamble that's just distracting us from solving problems we have right here at home? The United Nations Environment Program brings in a really crucial reality check here. Their chief digital officer basically cautions that we have to look at the full environmental picture. That includes emissions from all those rocket launches before we go all in. Are we actually solving the problem, or are we just moving it somewhere else? And so that's where we're left with this central conflict. Is shooting our digital infrastructure into orbit the brilliant, necessary leap we need to solve the energy crisis and unlock the next generation of AI? Or is it a dangerous, incredibly expensive distraction from creating a more sustainable future on our own planet? The race to answer that question? Well, it's already well underway.